Well, good morning, everyone. Welcome to everyone's probably first session here at Identiverse 2019. I thank you for being with me sort of bright and early on Tuesday morning. My name is Christian McCarrick. I'm the VP of Engineering at Auth0. And today we're going to talk a little bit about how do we build out and scale an IDaaS solution. So how many of you in the audience have ever had a product manager or a boss come and say, hey, we have this solution, we got a new customer coming on board, can you scale it? By how many? I don't know, a few million users by next week, all right? They're like, well, how hard can it be, right? You built this thing. Well, there's a big difference between building something and actually scaling it to meet the needs of all the customers or internal users that you might have. In today's talk, I'm not going to go into the why building an IDaaS solution. I think there's a lot of other talks about that, and if you're here, you're probably already very interested in one. But I am going to focus on how do we scale out a solution. And basically, that's going to be dependent upon our experience that we've had building one out and scaling one over the last 7 years. And the talk here is not going to be a step-by-step guide about how to build an IDaaS solution from the ground up. I think there's a lot of basic information. In fact, there's some other vendors here that could probably help you to do that if you need. But hopefully by the end of this talk, you'll leave with a better understanding of the potential challenges, understand some of the things you might not have thought about, and hopefully have a couple of tips to help you on your journey of building an IDaaS and scaling an IDaaS solution. Quick question for people in the audience. So how many are building or running IDaaS solutions that are primarily internally based? Enterprise, corporate, right? A handful. Anyone for external building IDaaSs externally, external customers? Okay, a little bit about half. That just helps me guide some of the topics I want to go into today. So why do we care about scaling? Right? Too often scalability becomes an afterthought. And it's usually a reaction to an unfortunate, already overloaded system. And by then, you're just being very reactionary. You're trying to catch up. And more often than not, the challenges of scale appear more frequently and sooner than you might think. Now, there's also a balance between putting too much thought into scale early on and premature optimization. I'm sure you've all heard this talk before. And if you're really early in your building out a solution, if you're doing it for external, the most important thing for you probably right now is actually getting product market fit, right, versus working on scaling. If you're building an internal solution, the most important thing for you right now is actually probably working on a proof of concept, getting buy-in from some of the other stakeholders in the organization. Once you do that, then really start thinking about some of the scaling challenges. But focusing on them too early could actually make you not get into that product market fit and have a project that actually might fail. So integrating identity infrastructure and apps requires evolving from one on the left side here, moving from a one-to-one model in which your number of credentials, the number of users times the number of apps, to B, which is the number of one-to-many model, into the number of credentials equals the number of users plus the number of apps. And when graphed and you look at the equation, especially on the left, it means that for each new connection you make or deployed, there's going to be a direct corresponding increase in the amount of credentials required. And increasing both the new users and the number of apps is actually going to give you an exponential increase. And that's why scaling challenges come up so frequently. If anyone's familiar with the authorization and depth concept, basically the concept captures that there's varying granularity of authorization practices across mainly 3 levels. But level 3 is the most fine-grained level, fine-grained authorization, controlling access to views, sometimes called entitlements. And the reason I put in here and tying this back to scalability is because the greater the granularity, the more authorization requests that your service is going to have to support, thus the need for greater scale. So what goes into building an IDaaS solution? If you see here, there's a couple of core pillars that you have to build no matter what, right? Compliance, scale, reliability, and security. And you have to have all these, including the ability to be trusted by your users and potentially your customers. And these are all topics that I'm going to be touching on today. Once you create sort of the basic pillars, then you have to add on some other things that are actually features that are going to make your service valuable. Again, these are common whether you're going to be building a solution internally or one for externally. You have to build in identity providers, authorization, protocols, user management, search, etc. Without these, your service doesn't really have a lot of value to the users that are going to be using it. And then to simplify adoption, educate, make your service easier to use, to build upon, you need to focus on the end user experience. And the end user in this case most likely being the developer, internal or external. Things like self-service dashboards, SDKs, docs, all these items are critical, but they're often not really considered during the design phase, architecture phase, and certainly not during project estimation. But you can never consider sort of your IDaaS solution done unless you also have these ancillary services and ancillary things built on top. These are the things that have an exponential effect on scaling, and they'll be instrumental in helping you scale your business exponentially and giving you ongoing support for operations and user acquisition. Now layer that on top of everything, and you have a layer of extensibility. And why is extensibility important? I'll get into that a bit later, but just like your customers might need, you can develop things that you might not have today, that you can engage your customers, professional service, other internal application developers to build on top of your application, which frees up your core developers and your core resources to focus on your core identity app. And I'll get to that a little bit in a little bit later as well. But building on an extensible piece of your application can really help drive user adoption and make your internal adoption much more successful. So now let's move on to some technical specifics related to scalability and reliability. Again, if you're just starting out, or if you're building a solution that's going to support maybe 500 concurrent users, you're not going to run into some of the scale solutions that we've run into and I'll talk about today. However, reliability, no matter how many customers you have, is always going to be equally important, whether you have 1, 10, or 10 million, right? The fact that you have to keep your service up is always going to be super important. And another note, that reliability tends to become harder, more complicated, and more expensive with increasing system usage and scale. So the more that you can try to focus on doing these things up front, the cheaper and easier it's going to be in the long run, right? It's a balance between, remember I said before, premature optimization and leaving it to the last minute when your servers are on fire and falling over. Back in 2014, logins for us at Auth0 were measured in the thousands, right? We were just starting out, hadn't really hit a lot of scale. And now we're serving over 30 billion logins a year and moving really into exponential growth. And of course, like a lot of companies and a lot of startups, we started off with kind of moving fast and unfortunately, sometimes breaking things. But that's not the case anymore. If we break down, millions of users cannot access their data. They can't log in. It's very interesting. My daughter doesn't really understand 100% of what I do. But when I tell her, oh, if you log into Fortnite, not that we provide Fortnite, but if you log in and you can't log in, she gets, I'm like, oh my God, like, how could I not log into Fortnite? So every time something breaks so she can't log into an app, she thinks that my company has broken the internet, right? But you have to tell her no, but then she thinks that's pretty cool. So I guess being cool for your daughter is always something pretty cool. The other thing about scaling too and reliability that's important is it's not just about having a stable API from a reliability standpoint, it's about keeping that API and your service backward compatible without any breaking changes. And honestly, that's one of the more harder challenges of scaling and running a service like this, making sure as you add more features, as you upgrade your services, that you don't introduce breaking changes and that you can have deprecations without breaking your customers, because that certainly loses trust very quickly. So some general techniques. If you're just starting out, building an IDaaS solution, a lot of the same techniques that today you read on the internet, you read blogs, you read books, that you would scale any modern SaaS application, a lot of these things you could take to in helping to scale out some of the internals of your IDaaS solution. Things like feature flags, rate limits, multiple availability zones, auto scaling. And the one thing I'm going to point out here that becomes super important for us moving forward is having a really good automated CI/CD process, really helping your continuous integration process. Things like blue-green deployments, canary deployments. I'll get to again and again about why these things are important, but it comes down to automation. It comes down to doing the least amount of things that you can do manually in order to focus all the efforts and your resources on actually developing your service and supporting your users. Rate limits. Rate limits are a powerful way to help you scale. Now, they do not absolutely help you grow your capacity, but they do help with overall system stability. In the early days, we started out with our own implementation of a token bucket algorithm and a local database, didn't have any HA. We figured, well, we didn't really need HA because if our rate limit service went down, we would just default to let users through, right? We then moved to a sharded implementation by partitioning the key space using consistent hashing on the client side. Still, we didn't use any HA for that. And now for us, and I'll get to this in a minute too, we also supported on-prem solutions. And adding networking and infra stuff on-prem becomes a lot more difficult. And in general, we probably would have done things a little differently in how we implemented rate limiting on-prem. In fact, we might not have even offered it as a service, but I'll get into that a little bit more as well. And right now, we moved to an implementation token bucket, which is implemented with custom Redis commands and a client that calls the Redis. This is HA, and we can actually stand up a clustered HA of that in front of every single service that we have so that we can actually scale our implementations of rate limiting. Now, rate limiting is interesting. Clearly documenting the rate limits that you put in place, communicating them to your users, and making sure that you respond with appropriate error codes if you are rate limiting is super important. We have been surprised about all the creative ways that our users can actually use and hit our services. One interesting thing that rate limits, this wasn't the reason we put it in, but it's an interesting thing that we've seen is a lot of customers or end users we have, sometimes they make mistakes. Sometimes they put infinite loops in some of their scripts, and rate limiting for us helps some of these accidental DDoS attacks that they put on our systems. Again, it's all accidental, but things like this really can help you, give an alert back. Hey, you exceeded your rates by a factor of 10 or 20 in this hour period. What's going on? Why? Are you really getting attacked? Let's not make sure this goes against your credential limits and everything else. Another specific scaling challenge we had was around password hashing. When designing a security service, you want to make sure that you store any passwords securely, and one of the most common ways to do that is with hashing. According to Jeff Atwood, hashes when used for security need to be slow. A cryptographic hash function used for password hashing needs to be slow to compute because a rapidly computed algorithm could be used for brute force attacks very easily. And especially with the Amazon, with the cloud, with rapidly increasing hardware, you need to be able to make sure you make those as slow as possible. Now, how do you do that? Well, you make them very complicated. If you use different algorithms, you can go through higher iterations, internal iterations, making it CPU and memory intensive. Now, a slow cryptographic hash function hampers the process but doesn't bring it to its knees, right? You need to support your well-intentioned users who are logging in, and you also want to make sure that you can thwart any bad actors that are going to try to iterate millions of times, over that particular password. So hash, everyone pretty much here probably, I'm assuming, knows about hash functions. One way, not like encryption. We use salt and pepper to prevent rainbow table attacks. If you look at the numbers at the bottom, using bcrypt as an example, you can see that the number of internal iterations that we have going from 2 to the 10 and 2 to the 12, you can see the increasing number of complexity and time it takes for the CPU in this case in order to solve those hashes. So you want to have that balance between making it too slow or making it too fast. If you make it too slow for one user, that's not good because you don't want them to take 5 or 10 seconds to log in. But if there's a slight hesitation, but it prevents multiple users from logging in, then that's great. And of course, these numbers are going to be dependent upon the hardware and the systems that you actually use. So one of the things we found, we were going through in looking at, these are the expected response times if you're going to do a performance profiling upon logging into one of your applications. The graph might look like this. Minimum greater than 0 because no request can actually take 0. Relatively similar amounts for the lower response times, and then kind of a longer tail because some requests just happen to take longer. Now, back in 2015, this is what our actual response times look like in a controlled test for logging into our system. You see that that's not quite matching with the slide I showed before. That showed us that there were going to be some problems there. Now, the first thing we look for in situations like this, maybe that we were just missing an index. It's something that actually happens a lot. You miss an index, and you could cause increased response times. Well, unfortunately, that wasn't it. So we kept looking. Our next hypothesis that there was some CPU task running that was blocking the event loop and causing requests to be queued. So instead of going through every single one of our pieces of line in our code base, we used a concept called flame graphs to try to cause the issue. Now, this is a generic flame graph. If you looked at a normal one, you'd actually have process names and the horizontal bars here. And we saw that most of our time was being spent on bcrypt. And bcrypt is the algorithm that we used for password hashing. And the problem is that bcrypt is very CPU intensive over long periods of time. So bcrypt computation takes hold of a CPU. And for those of you who don't know, we actually wrote most of our applications in Node. And Node is fantastic for a lot of things, but heavy CPU utilization, it's not really its strong suit. Right? So that was exacerbating this problem. But even if you have many threads, you'll still have this problem. The context switching can actually make it worse. So what you need is not just a scheduler to switch between CPUs or cores. What you actually need is really more cores. And so what can we do to solve for this? Well, we could have made our hashes faster, but as we just talked about, that's not really going to be good from a security standpoint. We could have looked into caching, but again, as we looked at, caching wasn't an issue. These are real-time logins, so we really couldn't cache their information. Scaling up, that's always an option. And we actually, from a short-term perspective, scaling up worked, right? We said we needed more cores, we could get more cores. But it can be very manual, it can be very expensive. You know, do you get boxes with one core on, if you're on Amazon or something, do you get a lot of boxes with single cores? Do you get boxes with multiple cores? How do you handle that context switching and locking? So what we did is scaling out. And we liked a lot of the benefits of a scaling out solution, but we wanted a little more control over the bcrypt operations. So we came up with something that we called BaaS. And for BaaS for us is basically a password hashing service. We created a TCP service that uses protocol buffer to handle two types of messaging: comparing a password to a hash and hashing a password. Each BaaS instance is like a worker in a distributed thread pool, kind of like distributed async mode. Auth0 needs to connect to a load balancer. There's actually two for HA, and then distribute the load between our BaaS instances. And this was ideal for a service. It had clear boundaries, it was very stateless, and it scaled horizontally easily. And since we were hosted on Amazon, it was actually very easy to use auto-scaling to scale this out to meet any load that we could come onto our systems. Another example of the scaling challenge we had over time became with our user search functions. User search is a key part of user management, and user management is a core, to IAM. Search functionality can get very complicated very quickly. Multiple SDKs, multiple mobile devices, internal queries, searching among multiple databases, shards, etc. And one of the more complicated pieces, which we'll run into in a minute, had to do with allowing unique, very custom and ad hoc user searches against our system. Back when we started with MongoDB, and everything we ran was in MongoDB. And we started our first search implementation, our version 1.1. We exposed our search API. It was on 1.0 on MongoDB. Fast forward a couple of years, and we started running into some issues with MongoDB, and it was related to user search. From there, we ended up moving to Elasticsearch, and I'll go into a couple of the reasons why Mongo at the time didn't work for us. Mongo, for the most part, had issues for us doing case-insensitive searches. And the Mongo Query Planner Index selection and query execution was not really optimized for regex. And we need regex for us to support case-insensitive search, which is a product feature that we had. And it was causing us a lot of performance issues. Also, if you wanted to search on metadata fields in Mongo, you actually had to create an index for each one of them that you wanted to create. So you had to pre-create indexes for them. It became very time-consuming. Elasticsearch, however, indexes things much better. And you could search for anything in metadata using Lucene Search Index. I'll get into why allowing Lucene Search Index on anything became another issue for us in a little bit. Fast forward another 2 years, and we started seeing issues for performance on Elasticsearch. And one of the big issues we had was we had too many fields in Elasticsearch, and that was affecting our overall search performance. Again, with the all Lucene syntax available, we were able to do any kind of queries, and it's a lot of those ad hoc queries that actually started to give us a lot of problems. Our next solution involved moving us to Postgres on a data store fronted by Java services on the front end. The other thing that's important to look at when you scale is it's not always about replicating exactly the features that you have from version 1, say, to version 2. One of the core things we saw that was affecting our performance was the ability for all our users to use ad hoc queries. Now, if you look at we analyzed all the queries we had, we took the most common ones, we're able to combine them into a set of predetermined queries that we could optimize in advance, right? And that really helped the performance that we had. And then we dropped the ability for full ad hoc queries. Some customers and some users we had concerns with that, but we worked with them to find ways that they could get the data they needed without that. One of the other things we also did was instead of supporting synchronous type requests for every single query we had, we implemented some batch and asynchronous queries so that these wouldn't be locking type of queries on our database. So I want to go over here one other concept, right? I keep talking about changes. We evolve and we change. And how do we do that? Well, it's easy to make changes in an architecture when you have a very few number of users. They're small. But remember, at this point, we had grown to about 12 billion sort of logins a year. And we were serving mission-critical requests from all over the world. So how do you make a change when you can't really have downtime and you can't really introduce breaking changes? Well, We actually mirrored the traffic, in this particular case for our search example, to our Elasticsearch service and to the new Postgres service at the same time. We split routed the traffic. We used a concept called tap compare, which was inspired by GitHub, to get the results from the new version of the search and compare it to the old version of the search. What you see here is the red number here. When you compare the result sets from both, the red lines here indicate the deltas between the two. This is where we were fixing bugs. This is where we saw feature compatibility that wasn't quite complete. And what we knew is that over time, as we started fixing them and become more compatible, as we had green for longer periods of time, we understood that that was a stable implementation that was really going to match our external one that was currently live in production. And then we could just switch over and run over to that with zero downtime and zero affecting for our users. There's, if you search on GitHub for this too, there's an actual, you can have download and use this tool as well. So another piece here. So where to host? How many of you here host your applications in a private data center? Your co-located private data center somewhere. Anyone else hosting them in GCP, Azure, AWS? All right, a little bit more, both. Yeah, that's another combination. Yeah. Did you start locally and then started expanding into the cloud? Yeah, pretty common. So the decision of where to host your IDaaS may not rely or depend upon a lot of people in this room, but there are a lot of benefits you can get by scaling, by going to one of the cloud hosting providers, AWS, GCP, or Azure, Heroku, if that's what you're on. So for us, when we first started, in order to properly scale and build out a solution, even just to serve a simple SDK, you need a whole lot of things, servers, networking, all that thing. So we decided to deploy our service initially just in AWS, full cloud native to start. Although we deployed our service in AWS, we actually were able to offer our services in a couple of different deploy options. We supported on-prem, as I mentioned earlier. We supported AWS single tenant. We supported Azure single tenant. And we supported AWS and Azure multi-tenants. Now, when you're a small company just starting out, this is a lot of places to sort of host and be able to support your application in. Very high level, back in 2016, of sort of the database architecture we had that was actually going to be, it was replicating itself through all of our different providers. Again, it adds some level of complexity. As we grew and scaled, we had to evaluate the cost of supporting all these options, time, resources, and opportunity cost. For us, the answer was to no longer support Azure in a multi-tenant environment. We could still support single tenancy on Azure because that was just the same as our on-prem solution. But we removed the complexity of us having to support multi-tenancy applications both in Azure and AWS and GCP. So as you see here, pretty much the same, except we dropped support for multi-tenancy in Azure. Still running everything from our core servers in AWS in a multi-tenant environment. Moving again, this is back in, I think, 2017 or so. It shows that our architecture has evolved a little bit. When we changed to just AWS, we kind of made sure we sort of had manual failover between regions and automated failover between systems in current regions. As an early IDaaS provider, as I mentioned a couple of times already, we supported an on-prem appliance solution, as there was pretty much demand for that offering back then. However, continuing to support that on-prem solution became more difficult. It was hard to sync on updates, different levels of access permissions, different hardware. One interesting story that shows some of the challenges of supporting on-prem for us, we had a very large customer with very large data sets, and they called us because their system was becoming slower and slower. And we went in to try to debug that solution. Well, remote is hard. Observability remote is hard. That's on-prem. Getting access to the system, if we could get SSH access, sometimes it was actually a remote viewer or shared screen. So as we looked at everything, we saw, well, the queries seemed to be fine. Indexes seemed to be fine. There weren't any slow queries. As we looked into the problem more and more, we actually saw that it was an I/O issue that was causing a lot of the slowdown. And our recommendation for on-prem deploys is to use SSDs. It turned out this particular customer was not using SSDs. And we spent many kind of 16-hour days rewriting their database config basically to get them and keep them up and running. Because for this particular customer, it was going to take 3+ months in order to procure and install SSDs into their hardware. Okay? So that was an interesting period of time. So remember that scaling is really looking at your total cost of ownership, right? It's not just about the technology, it's about everything you need to do. And because of that, we looked at the lower ROI, the decreasing demand for on-prem. We actually then pulled back our support this year for supporting on-prem deploys for our service. Again, it's constantly evaluating what is the most for you as you're scaling. It's not always about taking every single feature you have, every deployment option you have, and scaling all of them simultaneously. It's really making sure that you actually look at your business needs, your business drivers, and focus on the things that are going to give you the best ROI, and really focus your scaling on those. So again, as you see here, dropping support for that on-prem solution. Now, at this point, we've clearly chosen the cloud as our sort of data center, as our provider. We've happened to choose AWS, but any of the cloud data providers could be fine for any of you just starting out, right, based upon your particular needs. We've also found only advantages for this, right? The advantages go beyond speed and scale. They're easier than traditional run data centers, and for us, one of the most important things for us is they're built with automation from the ground up, and automation is one of the things that's really helped us scale and continues to help us scale as we grow. And as an IDaaS, whether you're internal or external, it really doesn't matter where you host. You know, your customers can still use your services. Your customers can still use their services even if they are self-hosted in their own data center or in their own offices. Okay? We have many customers that are using Azure or GCP. It doesn't matter. They can still use our services fine, just like they'd be able to use any of yours. So location. Why should you care about where your service is running? In 2014, when we started, it was probably less important than it is today. But servicing logins from all over the world really makes the equation a bit more complicated. Geopolitical boundaries often have data compliance and data sovereignty issues. The need to offload requests to different locations, and really a growing need for us, as we see, to reduce latency as much as possible, especially over large cross-continent type differences. You know, really, we see a need to support less than 500 millisecond response times round trip from any request from anywhere in the world. These are currently the regions that Auth0 is hosted in for our public cloud. And this covers most of the population from either a latency or a country region compliance specific standpoint. But if you're thinking about scaling and growing an IDaaS solution, you're going to have to really take into consideration that you really are going to need to be deployed in multiple locations. You just can't really do it without being that way. And this is another example where using a cloud hosting provider by default can really help you to go into other regions without too much extra work. Now, security. You can't really build and run an IDaaS solution without focusing on security. Well, I guess you can, but it's probably going to last very long. But security just doesn't mean access to your services, your network, your data, right? It's also about providing advanced security features for your customers. And the thing about security is that when you're small or little, like it's a little bit of security through obscurity, but that really goes away. The bigger you scale, if you're supporting high visibility customers, the more you have a big target on your back. And the more bad actors are going to try to actually get into your services and your customer services and networks. Now, security work shouldn't be underestimated. We have to do things like reviewing code, regular pen tests, open source and third-party vulnerabilities, lots of tooling in there, white hat programs, and many more. And we have an entire teams dedicated to doing this. But there are tools out there that can actually help you to implement some of these security things if you don't have a big, large compliance departments to do that. So what are some of these tools that are out there? Has anyone heard of using a tool like SNCC? Right? If anyone is developing programs, using any open source tools, a tool like SNCC can really help you alert to and point out vulnerabilities and even help you upgrade to those third-party vulnerabilities pretty easily and quickly. Right? It's an easy tool you could use. You can also use static code analysis tools like Veracode, and there's tons of other ones out there. And code review check-ins to check in for OWASP security best practices. And as I mentioned before, the CI/CD process, these are all tools that you can build into automation for that. So your developers, your ops teams, they don't have to actually do any of this manually. And by automating as many of the things you can, really, really helps you to do the scalability that you need to move forward. SNCC is also interesting. They have a new tool that can help you if you're on containers, that can actually help you scale and scan your containers on deployment. So verifying identity is not enough. Not everyone has good intent, so you have to assume there's going to be bad actors out there trying to get into you or your customer systems. And it is your responsibility as an IDaaS provider to provide and watch out for those. The other thing about running an IDaaS solution is you'll see a lot of large spikes in traffic. And sometimes it's hard to determine whether it's one of your customers or one of your users is having an event that's just launching. Whether it's a TV service and their users have to log in and they haven't logged in a year. And all of a sudden on one day you have 13 million password forgets. That's going to give you a huge spike. But what also looks like a huge spike, like large DDoSes or brute force attacks. So it's really important to start building and monitoring and tools you have that you can make sure that you allow the legitimate access through, while also trying to curtail the bad actors that are coming in for malicious attempts. In 2015, there was a very large and well-publicized and embarrassing for some people password data breach. This data breach, we are still seeing credential stuffing attacks using the results from that in 2019, now 4 years later. And the computational load required to scale against these types of attempts is also increasing monthly. So there's some decisions to be made to how can you handle some of these. For us, we have to decide how many leaks do we want to compare against. Remember, we store hashed passwords, and comparing hashed passwords takes time. So when are you going to compare against these? If you do it against every single request, that lowers your response times to your user, and you want to balance that from not having a bad experience for them. When do you compare? I mean, today we actually compare against everything, but there's an improvement even for us as we look at moving forward to compare for the leaks against only if new passwords are added from a breach database or if the user's password has changed, right? The important thing I'm trying to say is we are also constantly evaluating ways that we can look at how can we improve our scale. Because again, when we first started, it was okay for us to compare hash passwords to every single leak, every single login. And what we're seeing now is that is actually starting to become more and more computationally intensive and time-taking. A couple of other things we have done that can actually help speed this up a little bit. And again, this is using the cloud that can really help us. We designed a multi-region replication using AWS merge databases and managed databases, which is actually pretty neat. We sync those hashed leaked databases all over to each of our regions, and that happens automatically, again, power of the cloud. And we're able to do our queries with very low latency by doing that. The other thing is we have a process that automates ingestion of password leaks. And if those passwords that are leaked happen to be in clear text, you'd be surprised. It still happens. We'll hash them so that we can compare against them in our own databases. So these are, again, if you're thinking about running an IDaaS or you're thinking about ways to do that, these are some things that you can do to help with some of the breach password protection and protecting your users and their users. So it's also your responsibility as an IDaaS provider to handle pen tests, compliance, security, internal, external security, remediation. You have a lot of need as a provider and very specific legal responsibilities to alert your customers to potential security threats and found vulnerabilities, right? We found that building a central function to handle all these things actually is the most efficient way to do it instead of having each team having to handle these things. Having one separate function combined, you can use sort of one person dedicated or one or two people instead of people multitasking on your different teams. Often discussed in hand with security is compliance. I mean, I am very, very passionate about security. Compliance makes me a little crazy. And I apologize if there's any compliance legal people in the room. But every day there's a new compliance spec. There's something else. I'm being audited. It's never not the most fun part of my job. But meeting various compliance regulations is a must-have for any IDaaS provider, especially if you really want to grow and scale. If you're going to want to get larger external customers, they're going to demand that you have compliance, certifications, attestations, et cetera. And this is also true for internal IDaaS solutions. If you're building a solution too, you're going to fall under the compliance regulations of the rest of your org, and they're going to want to know exactly too how you fall and fit under those compliance regulations. So how can you help? What are a couple of things you can do to help scale your service while maintaining compliance? Well, let's just choose like PCI for an example. PCI compliance, there's a lot of third-party companies out there like Stripe. You can use another SaaS company, Stripe, to offload all of your credit card data so that you don't have to actually hold it in your service and your databases. And also, Stripe is an interesting one where you can actually have that data passed directly by your networks and not even have to go through your network. And that's one of the ways And there are other ways like that where you can avoid compliance by sort of taking it out from your purview, right? Avoid it by not having to deal with it. And there's lots of other things like that too. The other thing too is, which is really important, this is where creating architectures with really clear service boundaries and service-oriented architecture can make a lot of sense. The thing that you want to do is really limit the surface area of the product that you have that's going to fall under a compliance realm. Right? It's some of the stuff that we've done too. We don't necessarily need to have every single piece of our application HIPAA compliant or PCI compliant. We try to carve those out so with the smallest possible surface area as well that we need to get compliance for, and it reduces the cost, it reduces the time, and it reduces the complexity. And also, as mentioned previously, there are things that you can piggyback on for using cloud hosting providers like AWS. They're all SOC 2 and HIPAA and in some cases FedRAMP compliant. So there's some places where you can piggyback on their compliance certifications to give your company a jump start on getting ahead. Extensibility. I mentioned it sort of in the beginning. So why extensibility? Why is it important? This is not something that's often talked about in scaling. But for us, we found that it's been an instrumental way that has helped and enabled us to scale quicker and faster. So kind of why? Useful for product discovery, empowers developers to do integration and customization. But one of the core things that we found that really helps us scale is this middle one, where it does not require changing your core product. By spending the time to build in some extensibility endpoints earlier, there's a lot of wins to this. One, you can have your customers or your end users develop things that they need, which can speed up their time to launch. Right? If they have things, it takes the resources from you that you don't have to focus on developing one-off features for lots and lots of different internal users or customers. And one of the things too is it allows you to deploy things, or your customers and users to deploy things that might not have to go through your traditional change management process. And I know a lot of companies, especially larger companies with compliance, getting things through a change management process can be tricky and time consuming. So what are the things when I talk about extensibility? Custom email providers, OAuth compliant identity providers, custom actions on login, sign up, etc. One of the things we built the ability to do was have custom SMS providers. Now, we supported Twilio right out of the box, but as we started to scale globally, we found that a number of developers at some of our companies could not use Twilio, and they needed to use their local telecom. So by enabling this, actually, we were able to develop very quickly with the customer a custom provider for their telecom SMS service without having to touch any of our basic code. And that was able to be done like in a few days instead of potentially weeks or months having to go through multiple change management, get it into our backlog, and get it into our release process. If you want to figure out how would you do this, we've built a custom serverless platform. We made it low latency, no cold startup. We sandbox everything. Want to keep this thing very small because we know people are going to run and execute any sort of code in there. Extremely limited permission set and siloed. If anyone's looking to start off today, I would have probably built something like this in Amazon Lambda. Right? Lambda is a very good implementation where you can actually use something like this. It's built up for you. It scales well. It has good security constraints. So I think today investigating Lambda as an option for this would certainly make sense. One thing, again, that doesn't really get talked about as well is the user experience, especially as engineers. We don't always think about why is the user experience so important. Well, today, we live in a globally interconnected world, and unless you're designing a service for a very specific region or a country, you're going to need to make sure that your service can support multiple languages. Not only support multiple languages, but if you're going to providing any login pages or whatsoever, you need to also make sure that you can focus on accessibility. More and more people accessing the web. With disabilities, you want to make sure that you can service them as well, right? You want to make sure that your public assets can be localized to be able to support and grow and scale your service internationally. Another important thing to think about is performance. We also don't think about performance. And we especially don't think about performance as we're creating things from our laptops that are on the same networks and testing against AWS with extremely short latency in between them. I'm not going to get into performance about discussing JavaScript optimization here, but minimizing JS, using external image and JavaScript caching providers, CDNs, these are all things that can reduce latency and outbound traffic costs. As you really, really start to scale and grow, the thing you don't start to think about is your AWS and your web hosting or your traffic hosting costs. I will say that our largest OpEx today right now is actually Amazon costs. So, and they can grow and they can start growing linearly. And the things that you want to watch out for is making sure as you grow and scale that your Amazon costs or any hosting provider costs you do can grow, logarithmically instead of linearly, because that's not a scalable solution. Okay. I've mentioned this a couple of times again. SDKs, quick starts, reference implementations. These are all super, super important for scaling as a whole. It's also hard to keep up on these. If you have an SDK using underlying tools like React, well, that changes like every other week. So, you constantly have to update your SDKs to support them. The number one reason that we see customers churn to is for failure to launch. And by providing these things, whether it's an internal solution and you're trying to get buy-in from internal teams, you're trying to get buy-in from external customers, if you can ease the adoption route and the on-ramp for your customers to be able to use your service, you'll have a much higher adoption rate and a much higher, ultimately, success rate for any IDaaS type solution you're trying to put together. These are all what we consider multipliers too, and they help the business scale most by not having to have your high-paid technical resources hand-holding to do customer support and implementation. Now, relationship management. As much as engineers sometimes would like to think that customers in general don't exist, actually the opposite is 100% true. Like, we exist primarily to provide value to our customers. And providing value to our customers is not just giving them a service. It's actually providing that service, making sure it's up, being able to answer questions when they have issues, being able to help them, guide them through their implementations. Right? If your customers can't log in, their customers won't be able to log into their services, purchase things, run their business, etc. And when scaling an IDaaS service, it's actually, again, not running their service, but helping them get the service up and running too, because they're not going to be customers and they're not going to be internal users if they can't successfully create and integrate their platform into your IDaaS solution in the beginning. And these are all self-serve models. They support greatly reducing the burden on your tech support staff. And one of the ratios that people think about when they start scaling too is making sure you have a lower, support person to customer ratio. Those things become very important when you scale. So, what are some other ideas you can do to help scale some of your customers? A very simple thing is a status page, right? This, again, goes to a many-to-one model. Are you having updates? Are you going to have any downtime? What's your release window? Do you have software changes coming? Do you have any deprecations? Do you have a potential outage? If you have any of those things, you can also automate this. If you have any alerting tools, you can have your status pages automatically be updated. Again, take that human intervention piece out of the middle, helps you use your resources more wisely. All right? Focuses again on automation. Automation as much as possible. If you have logging or alerting tickets, have them automatically create PagerDuties, have them automatically create Jira tickets, etc. Again, it avoids that person in the middle to help you do those types of things. Support and 24/7. Most of you are going to have to support your applications and your customers' applications 24/7. What are some things to help with that? Some services out there, PagerDuty, VictorOps, there's a couple of other ones, ServiceNow. There's a lot of other ones out there that can actually help. Use a tool and focus on taking the energy and time to actually implement it the right way. I know there's a couple other sites too. PagerDuty has some really, really great documentation on incident management, incident response. If you're trying to build one out for your team, pretty much you can copy the playbook right from that company and it'll really give you a head start for that. One of the things we do at Auth0 is we have a concept called goalie rotations, and this isn't for on-call, but we have one team, one dedicated person, a team, either for a day, a week, or a sprint, and they're the person that's basically intercepting all of the interrupt-driven work that happens. This allows the core teams themselves to really stay focused without being distracted, helps to keep them in that zone, and helps our overall velocity predictability. Okay. Doing 24/7 support, if any of you are global companies, or you can think about hiring remotely, being able to have people that are in remote time zones can really help avoid the burden of having people to do support when they're in bed and they're off hours. Now, a common theme from scaling is that the harder things get much and much harder the more concurrent users and load you have on your system. Take something like a breaking change in an API. If you had a breaking change, you had 5 or 6 or 7 customers, I could probably pick up the phone and call every single one of them and walk them through that change, right? However, well, that becomes quickly and practical as you add more users, more platform, more load to your systems. So how do you do it? As I mentioned before, breaking changes, deprecations, one of the hardest challenges we have. One, try not to let it happen. Have a really high bar with a release process where you have approvals to implement any breaking changes into your code. Consider building API versioning into your code from the get-go. Now, not all the things that we do are REST APIs. Okay, so REST APIs are a lot more easy to do versioning in than some of the other ones we have, but still, try to put some type of versioning into any of the solutions that you offer. Batch any changes you need. Nothing irritates customers or your users getting changes, one change a week, you have to change. Batch them up quarterly or some other way. It allows them and your customers and your users to implement and fix all those changes at the same time. And again, for them, especially if you're dealing with some larger organizations, it allows them to batch all of those changes into one change management request, which will also make a lot of the developers that you have happier as well. And communication and official policy. Give your users, say, 6 months upon notification of a change, that they have 6 months or so in order to make the change before you turn it off. Now, the exception for that is seriously going to be around zero-day exploits or high or urgent security vulnerabilities. Those are ones you're going to have a separate process for to implement immediately. So I think, and sort of just high-level wrapping this up, writing code is just the beginning of an IDaaS solution. If you want to really truly scale your solution, it's going to require commitment, time, resources, and many people and many teams working together. And scaling an IDaaS solution is a continual journey. This is not just a destination. You build it, you're done, you hand it over to IT department to run. Okay? No one knows all the changes that are coming, the changes to the specs, the challenges we face tomorrow. But I do wish every one of you the best of luck in your journey, and I'll be happy to discuss this, things I didn't talk about, things we want to go into more detail with any of you all. I'm here this week, and I think there's some time, too, for a couple of questions left. So, thank you. Anyone have a question? Yes? I can hear you.
Okay.
I'll repeat your question.
I wanted a little clarification on one of the things you were talking about with regards to your service providers. As you were talking about how there is the expenses would change logarithmically. You said be careful of that, but are you talking, what was it that you were talking about changes logarithmically? Because that doesn't make sense to me. That was the question.
I'm sorry, from a cost perspective?
Yeah, right.
Oh, sure. Yeah, I mean, ideally, basically, I'm just wanting to make sure that when you're scaling, both from looking at the computational cost of your software that you're putting, the logging that you're putting together, everything else, the main point I'm really trying to say is you want to make sure you can't go into an exponential growth, and you want to make sure that even a linear growth is actually going to be, too much. You want to try to get that lower than a linear growth in order to support scaling properly.